So yeah, thanks for coming out. Tonight I am going to talk about web components and why they're not going to save us, not on their own anyway. So maybe you're thinking, save us from what? To get into that, I'm going to talk about the state of web performance a little bit first. So in many respects, we're living in the future these days as web developers, or I feel that way anyway. Good performance is easier to achieve than it ever has been before. But not everyone is experiencing the web the same way, right? As the saying goes, the future is here, it's just not evenly distributed. The way people experience the web today is highly dependent on their circumstances. And that's because our work is delivered to a diverse spectrum of devices and network conditions. Popular mobile devices performance has really diverged in the last 10 years or so. This is a updated post actually from this week from Alex Russell. He writes a really nice article, kind of a series on this every year. He happened to post a chart this week that updated it for this year, so I caught that. It shows performance benchmarks of popular devices in the last decade. And 10 years ago, all the devices were kind of similar in performance, which is to say they were pretty slow. And nowadays, that is not the case. A new iPhone may be 8 times faster than a new budget Android device. And by faster, I mean how efficiently it can download and, more importantly, churn through the code that we send it, especially JavaScript code. Now, if you intend to deliver fast experiences to people just in the US, your job's going to be a little bit easier. This is the Amazon bestsellers page for the US mobile phones. Generally, all these devices are pretty capable, mid to high end, lots of iPhones, Samsungs. So that's relatively easier to support, but a lot of companies, of course, care to reach a wider audience. And if you look at that same bestsellers list in other regions of the world, like India, for example, you get a very different set of devices. And it's not that they're all low end, especially not now. A lot of high-end devices in this list as well, but the spectrum is a lot wider. A lot of these devices cost $50 to $100, and they're relatively underpowered compared to what a lot of us in this room probably use day to day. So that kind of sets us up as developers with an interesting challenge, right? With exception, we tend to have access to nicer devices, faster connections when we work, and experiencing our own work every day under those kind of relatively ideal conditions can give us a skewed perspective of how the people we build our sites for are experiencing our work. I made this kind of crude timeline to reduce the entire history of web performance into 2 phases. Websites have been slow the whole time, but for different reasons. Basically, in the early days of the web, like prior to 2013 or so, I would say, it was hard to deliver websites quickly because the constraints were there that were beyond our control, network constraints especially. Sometime around that middle period, it's safe to say the influencing crowd in our industry started to experience the web with reduced networking constraints. Cell networks got a lot faster, devices got better. Really quickly, the way many of us popularly delivered websites changed. And that change in practices ensured that we'd continue to provide poor performance to some users, even though conditions had improved. Which is another way to say that around that time, we started shipping just a ton of JavaScript, right? And on our own machines, perhaps that seemed to load and download and run pretty quickly without much delay, but byte for byte, JavaScript is the most expensive asset to parse and run after downloading on a device. And that really starts to show up on slower devices especially. And worse still, around that time, more and more websites were starting to use that JavaScript to actually generate the HTML to start with after it was delivered to the device. So React popularly entered the scene with a component model around this time. It, for a while, ran entirely client-side as the way that most people used it, turning the server into kind of a JSON API for us instead of delivering HTML. And that was a pretty fundamental change in the way web content was popularly delivered. And that's a shame because we knew already at that point that there is actually an unopinionated correct way to deliver websites to a browser. And handing the browser a box of parts and instructions on how to put HTML together is actually not that way. I drew this IKEA box, by the way. That's web page in Swedish. It looks like website. It would work for that too. If you've put together IKEA cabinets before, you know it can be a trying experience. They're asking a customer to do stuff that not everyone is good at doing on their own, let alone quickly. And this is sort of the same situation, right? Browsers are designed to receive HTML as static text and quickly identify resources in that HTML and start fetching stuff even before rendering it for display, even before making a DOM out of it, right? It's called the preload scanner. So a lot of stuff happens if you can give the browser HTML as text up front. They're kind of designed to receive a cabinet that just needs a coat of paint, right? Instead of a box to put together. A colleague at Squarespace used to call the React pattern outsourcing our compute, which I think is kind of a funny LinkedIn way to say what we're doing. So I bring this up because JavaScript over dependence has been kind of a primary performance bottleneck observed across the web for the last decade. Just as browsing and browser and networking tech started to improve enough to alleviate the performance problems that we used to have, we kind of increased our payloads and dependence on them and made new problems of our own. And in doing so, we shifted the performance burden from the network to the devices. In recent years, there's actually been a really positive change in this regard, and I want to acknowledge it. And it's very cool that the Svelte creator is going to be at the next event because, yeah, he does amazing work. It took a while for frameworks to come around to the idea that client-side rendering everything, especially for regular old websites, is not the best approach. But they did come around. It's now very common for server-side rendering of HTML to be kind of the default. And I think Svelte talks about this a lot as progressive enhancement is sort of their default way of thinking. I think that's great. But just because we're server rendering our JavaScript app into HTML doesn't mean we're fixing performance entirely, right? So like Next.js is probably the most popular framework for this server-side and client-side React sort of rendering pattern. It serves HTML, but it still serves a ton of JavaScript to the client. And if you look at their core web vitals, you can see that they're struggling to compete. This is public data versus other frameworks and tools that don't rely so much on JavaScript on the client side. It's just hard to make client-side JS that's that heavy perform really well. So to move beyond this period of JavaScript bottlenecks on the client, we need to look for ways to ship less JavaScript and rely on it less. Today's performance problems are best observed on devices like this, a budget mobile device. How do we know if we don't happen to have one lying around? I think we should have one lying around. This is one of mine at work at Squarespace. We have a few in the device lab, so to speak. This is a dev tool. We should all have these. And bring them out from time to time and check the qualitative experience of what you're building in addition to just the metrics that we all track already and automate, right? I like to call it vibe testing. That's a term I'm trying to make happen for the youths. If you're doing this sort of thing, if you're testing on real devices like this one, I'd suggest getting this app called Charles. It's been around forever. If you're on a Mac anyway, does anyone know? It's probably on Windows as well. Yeah. Charles is great. It's a proxy with a lot more features than just that. You can set up a hotspot from it and meter the connection speed and share it to the device. And suddenly you're testing on 3G, 4G speeds. You can make packets drop like you're on an airplane Wi-Fi connection. Yeah, so really, really good tool. When you're done vibe testing, though, there are plenty of tools that we can look at for proper metrics to track our performance. This might be review for some folks in the room. I'm just going to go through it anyway, just in case. These metrics in particular are ones that Google has kind of called out as perceived performance metrics that are most important. They call them the core web vitals. LCP, that's largest contentful paint. That's kind of like how quickly your site starts to render visually. INP is interaction to next paint. That's about like delays in interactivity, how quickly the UI can update visually after you interact with it. And then CLS is cumulative layout shift, and that's like the jankiness that you see as a page kind of settles into place while it's loading. 0 is a good score for CLS. There are great tools to help us measure these things in a variety of ways. There are a bunch here. Speed Curve was mentioned, Calibre, Debug Bear. I've been using that lately a lot. Yeah, bunch of great tools. Most of them have free options. And synthetic and field testing options. So synthetic, like this is an example of a synthetic test in Calibre. That just means you go out and create a test yourself, as opposed to observing browser behavior in the wild from actual users of your product. So Calibre is really good for that. Then there's synthetic monitoring, which is like doing that same thing, but on an automated cron job sort of thing every day. Debug Bear has that. Debug Bear has just been crushing it lately. Definitely worth checking them out. Really good features. Then there's field testing, right? So otherwise known as RUM or real user monitoring. Basically every large-scale website does some sort of RUM today. It allows us to collect performance data from people actually using our products in the wild. And typically that's done by like a script tag in the page that reports phones home with some anonymous, hopefully, metrics of how the page is actually loading for people who are actually using our products. This is a view of Cloudflare's actually observatory. They announced recently that RUM is free, right? I believe, yeah, if you have Cloudflare. So that's amazing. There are also public RUM sources that you can just look up and find out how particular sites are performing, sort of in the past, at least. One is called Crux, that's Chrome User Experience Report, which I don't want to dwell on it, but I like to say that's not really how acronyms are supposed to work. But Chrome data is provided to Crux database. Chrome browser tracks anonymously and reports home to Google all these metrics about all the websites, and you can find out the performance of any popular site through Crux. For example, like this. This is like websites running on Squarespace in the last, well, I don't know, 5 years, LCP times. So you can find out things like that without setting anything up. Speaking of at Squarespace, RUM I think is pretty interesting there because those anonymized metrics come from, we collect them on our end as well, and they come from all users using all Squarespace sites all over the world, right? Millions of websites run on Squarespace. So we have this view across, a big portion of the web. And I think it's one thing to get up here and say, websites work differently for folks in different places where connectivity and devices are different. It's another thing, I think, to see evidence of that every day, right? This is LCP, so rendering times in different regions of the world at P75 and P90, so slower connections, 90th percentile. And we can see just how much, this is good. In Germany, we have good scores, according to Google's concept of LCP being good. But in different regions of the world, we see the same sites performing differently, which presents, I think, opportunities. Improving performance literally means broadening our customers' reach. So it's something we're always aiming to do, right? There's this great article about this from a decade ago that gets referenced a lot. I'm going to bring it up again because it's so good. So the story goes, has anyone heard this? YouTube Feather? Awesome. I know Paul knows this. So YouTube ran this experiment to serve a much, much lighter version of YouTube to see how fast they could make it load. And as their RUM metrics started coming in, they noticed something unexpected. And that was that on average, their new lighter version of YouTube was taking longer to load than it normally would on average. Why, right? Well, it turned out that this lighter version was actually so light that it became possible to use at all for a lot of people who couldn't use their service at all to begin with. And as a result, the average was worse, but they had brought more people into their customer base by improving performance. So it has this enabling effect, right? It's one of the things, like this story inspires me to do performance work. I just love that. Anyway, I've been talking about performance, but this is supposed to be about web components. So let's talk about those, and I'll bring it back around. I think that they're relevant here because they could play a part in getting us past this bottleneck of JavaScript overdependence. And that's because so many of the things that we have relied on JavaScript libraries for a long time now are built into browsers increasingly. So they're dependency free, right? And lots of big companies have adopted web components recently. So Adobe, for example, has standardized on them. They have this open source web component library called Spectrum. It drives a lot of their apps. It's really nice. To be clear, when I say like Adobe uses web components, like Photoshop runs on web components now on the web. Really complicated apps running on web components. This is Photoshop running in the browser. This is me using it online. As you can see, graphic design is my passion. If you were to open your DevTools in that same Photoshop app, you would see a lot of these little unfamiliar names. Maybe it's a little small for folks in the back, but we have like psw-app-navbar. That's not a normal standard HTML element, right? So these are web components. Adobe's all in on this. Apple is another web components user. The Apple Pay button, if you've ever clicked one of those on the web, that's a web component. You can see it right in their documentation. Apple-pay-button is the element. And yeah, that's the embed that you paste into your website. I'll come back to that because they have some cool examples. Microsoft, they've sort of standardized like Adobe recently, made some design frameworks out of it. This ad is from when they relaunched the Edge browser, rebuilt in web components also. So like the Chrome of the browser uses web components. And Firefox also does now. I'm actually not sure on Chrome. I meant to check into that. But yeah, they're even being used in native app UIs. GitHub, another big user of web components. You'll find them all over the place in the GitHub UI. Like this one, you know, anytime you see like the commit and how long ago it happened, that's a little web component called relative time right here. And you can see the actual date that gets passed into it. And in the UI, it says what the relative time since that date was. So that's kind of cool. And those update live as you're looking at the UI on some views. MDN, the best docs site for web standards, they just rebuilt in web components too. So enough appealing to authority, but I wanted to highlight a few of those. Let's talk about what these actually are. So they are not any one feature. They're actually a combination of several features, sort of like responsive web design is a combination of several elements. Web components are a group of web standards, and those are custom elements, HTML templates, and Shadow DOM, also slots, sort of comes with Shadow DOM. Let's talk about custom elements first. So this is a my element, which is an example of a custom element. If you know HTML at all, you know there's no standard element that's called my element built into browsers, and that's because I just made it up, right? That's the entire point of custom elements. They're real elements to the browser and to web standards, but you just make up their names and you extend them further. The way to know if an element is a custom element and not a standard one is that it contains at least one dash in its name. So they're like these little imposter elements that you see with little dashes in their names, like 3 squirrels in a trench coat pretending to be HTML. Actually, in fact, according to the spec, this is completely valid as a custom element. You can use emojis, Unicode in your element names. They can't be all squirrels. Has to start with at least one letter. I've really gone off track here. But you can use squirrels. There are a couple other rules as well. You don't need anything after the first dash, so like a dash is valid. You just need one dash in there or more. And they can contain special characters, underscores, numbers, squirrel emojis. They need a closing tag, so you can't just like have a self-closing element like, like a link element you would see with a closing slash on it sometimes. That's called a void element. Can't do that with custom elements. They need a closing tag. And that's something that, coming from like React components, you have to be aware of. Like you got to close it. These are real elements. They're not components in that same way. As far as browsers and standards are concerned, they're just regular HTML. So you can put it alongside other HTML like this, drop them into your page alongside your paragraph and your UL. Or you can wrap them around other HTML, which is my favorite way to use them. I'll explain why a little bit. But basically, you treat them like you would a div or something like that. They can also be empty to start and populated by JavaScript later. That's not my favorite kind, but mostly because too many are built this way, I think now, especially in the last 5 or 10 years of web component development. There's been a lot of that pattern of like, client-generated markup with web components, but there are good cases to do it that way too. So they can be empty. Since they're real HTML, you need to follow the rules of HTML, so you can't just drop them anywhere. Like a UL has rules about what its child elements can be. They need to be an LI, right? So you can't just put a custom element directly in like that, but you can put it inside an LI. All of this to say, we're writing real HTML elements when we use custom elements. So once you drop an element into the page, at that point you can think of it kind of like a div or a span, which could be enough, right? You can style it already. Maybe that's all you wanted, just like a nicely named container. That's fine. But using the custom elements JavaScript API, you can extend it further and make it into a custom element that actually does things of its own and kind of behaves like a native element that you would choose over another that's built into the browser. So that API is known as the lifecycle, the custom elements lifecycle, and it's the best part of web components, in my opinion. So it allows us to apply scripting at key moments in a component's lifestyle, like when it's first created, when it's found in the DOM, when it's removed from the DOM, when its attributes change. If you've worked with frameworks a little bit, these probably rhyme with a lot of the methods that something like React would provide, not natively. Now they're built in the browser, right? So to use the lifecycle, we need to teach the browser first about a custom element. We need to define it, right? So this one line of JavaScript does that. Custom elements.define. You pass the element name in, and then you provide a class. I'm going to unpack that right side a little bit in the next slides, but this is it. That alone starts to define that this is more than just a div to the browser. This is something that is actually called defined. There's even a CSS selector for that defined that you can then match on my element. So this is a new state, and then you can start to apply behavior in that class. So I'm breaking out that class here. I actually defined it with a name, and then that same line is now just using that class down here. So different way of writing the same thing. Inside the class, we have some methods. Some might sound familiar. If you're used to React or if you're used to writing JavaScript, there's a constructor, just like any class. There's also connected callback, attribute change callback, disconnected callback, adopted callback. Here's connected callback. It's kind of the DOM-ready moment of web components, except much better. So if you use, DOM content loaded natively, you would wait for the whole DOM to be ready before you could apply some scripting to it. This is much more catered to one element. And when its first tag is encountered by the browser, that's when you get your connected callback. So you can apply scripting in here that says, whatever you want to do to enhance the element right there. So that's sort of your DOM readiness callback. And more practically than like console logging, you might do something like, maybe there's a button in the custom element, and then connected callback. That's your first chance at having access to the DOM nodes, the child nodes inside that element, to be able to apply behavior, add event listeners, things like that. Okay. Don't use constructor for this. Use connected callback. Constructor is more like the moment when you create an element, maybe in memory, like document create element, that calls the constructor. It might not be in the DOM yet, so you don't want to run DOM methods on that element through the constructor. Connected callback, really useful for that. The other methods, so we have attribute change callback. That's kind of like for basic reactivity. It lets you know if the custom element's attributes changed and you have access to the old value and the new value. You can do a lot with that. Disconnected callback is when the element is removed, deleted, or just removed from the DOM into memory to be reappended again later. Maybe if you had like a long-running timer or something running on your element, disconnected would be a good time to pause that or cut your timer off. Adopted callback is when an element is in another iframe kind of context and gets adopted into another window. And frankly, I've never used that. I think it's like something the YouTube team probably needed at some point in the spec, and that's why it exists. Who knows? But it's there. I mentioned a second ingredient, so HTML templates. These give us a way to statically deliver reusable HTML inside our HTML document without rendering it. So it's just like defining some HTML that we're going to use later to append to, say, every list item with some certain formatting or something like that. I'll show you an example. So this is a template with an li element in it. That li does not get rendered visibly, but it's there for reuse by web components. So you could clone the contents of this template and populate it using DOM methods, append, make a list in your web component. That's about all templates do. So if you're coming from like a framework world and you were excited about templating and web components, yeah. But there are good tools for that. Okay, third major feature is Shadow DOM, and slots come with Shadow DOM. Shadow DOM is a relatively new thing to web developers, but it's been in browsers forever before we had access to it. If you're in DevTools, you can flick that little checkbox, and then you can start to see how browsers are developed with Shadow DOM natively. So a lot of like our favorite select element where you can't style the options, those are in Shadow DOM. They're not reachable. So it's encapsulated area that CSS can't get to in quite the same way. So yeah, I'd suggest turning that on in DevTools and just like looking around. So many native, especially like form controls, have shadow roots in them, and you'd be surprised the element choices that browser devs used to create them. There's a lot of divs in there. But yeah, it's interesting. So basically, it's a portion of the DOM that's encapsulated, so protected from outer interference from CSS and JavaScript. Sort of, mostly. I'll get to that. It's a little nuanced. So let me show you some more examples, because we can use Shadow DOM too. Why would you want to do that? I'm going to say that most of the time I don't. I think it's overused in web components. A lot of examples online, you're going to see Shadow DOM first as kind of like the way that things are built. I think I like to sort of use it as an exception, but sometimes it can be handy. One case that I think fits really well for Shadow DOM is if you're making HTML that's meant to be embedded on a different website than your own, that's a great use of it. You can just like document, like the Apple Pay button. Here's the tag that you need to put in, set the attributes, but don't bother setting any HTML inside it beyond that. We'll handle that with our script. So an embed is a good use case for it. Like the Apple Pay button, I said I'd come back to this. So this is the configurator for the Apple Pay button. You can change all sorts of settings, and you can see the button down here is changing as I change different settings. These are all explicitly exposed as settings that that the end user of the embed can choose. But otherwise, they can't really do much. They just have the tag and it's empty. You can't control the markup inside it. You can't really style it. You can't change the Apple logo to something else. That's very much their preference to not be able to do that. But you can configure some things on purpose. And they do that with Shadow DOM. So you can see, it's not huge, but you can see there's a shadow root inside the Apple Pay button right there. And all the styles and markup inside of it is controlled by their script, injecting it in. So that's how that works. How do we make it? There are a couple ways. Earlier I said the template element is kind of useless. It actually has another use. You can make shadow roots out of it. Not by default, but without JavaScript required at all, you can create Shadow DOM using the template element by adding this attribute. So once you add shadow root mode, closed is one of the values you can add, then you get over here, you can see just inside the body element where I had that markup, that template became a shadow root. And this is pretty cool. This is relatively new. You used to have to use JavaScript to create shadow roots, and now the template element can do it. It's called declarative Shadow DOM. So that's kind of nice. That's one way to make it. I could instead do it this way. So I'm using JavaScript to the constructor. So right when my element was created, constructor gets called. I call super just to make sure I get the benefits of the class I'm extending. You can learn more on that one. It's a big topic, but here I'm attaching a shadow root to it programmatically instead of declaratively, and then you can just set the inner HTML. This is what the Apple Pay button does, essentially, with a lot more JavaScript. So regardless of how you make that root, it's encapsulated from JavaScript accidentally messing with it. So I've got DevTools open here. You can see I ran document query selector for a paragraph in this context. And ordinarily, you'd hope to catch this with your query selector, but down here it says null. It couldn't find it, right? So that shadow root protected that element from being messed with, right? That's good. On the other hand, if I set the mode to open, you can sort of explicitly say you want people to be able to reach those elements, but only on purpose. A query selector won't find them still. But if you set the mode to open, here I'm doing it declaratively, then the console changes. And the way it changes is I queried for the div parent of the shadow root, and then I went for the shadow root property. And that lets you dig further into the Shadow DOM. So if you want, you can make that available to your customers of your web component. CSS selectors can't cross through in that same way. Whether it's open or closed, doesn't matter. Selectors won't cross the barrier. And I'll come back to that. This brings me to slots. So Shadow DOM comes with this feature called slots. Slots are little elements inside the Shadow DOM that let you reveal light DOM elements inside the Shadow DOM. It's kind of weird, but it's handy. Like, for example, say the Apple Pay button, let you add an HTML element or two that's going to get placed somewhere in their component amongst a lot of other boilerplate HTML that they provide. A slot can help you do that. Here I'm passing in a paragraph, and I'm attaching a shadow root and setting the inner HTML of the whole thing to a slot. And then what happens is this. So let me, actually, this was a separate, better example. Sorry to skip that. So here's a better example. I'm passing in just some text, and some boilerplate HTML says, look in the, and then there's a slot element, and this gets passed into that slot. So you can make like part of the HTML configurable, and it remains light DOM, so you can still style it like the rest of the page. Yeah, so that's sort of how you enable composability with web components, and a lot of the more advanced like Photoshop kind of apps use a lot of slots. They're like, you know, embedding lots of components inside one another. CSS encapsulation. It's a little weird. Shadow DOM is encapsulated from CSS, but not fully. So first, here's kind of a basic example. In the parent page, I've got a paragraph with the color red. So that should get the paragraphs in the page. Here's 3 of them. One of them is in the shadow DOM, okay? So styling all the paragraphs, and you can see the one in the shadow DOM. This is how it's rendered. Didn't get that red selector. So it's protected in that way, right? From the paragraph selector. But if I change that selector to body, which happens to be a parent of all of this, look what happens. They all go red. And the reason is inheritable styles in CSS break through the barrier of the shadow DOM. So what are inheritable styles? Color, font size, I don't know, anyone else? There's a bunch of them, yeah. So some styles go through. It's worth keeping in mind as you're writing styles. Some of those are gonna leak through. It's actually very useful, but it's confusing if you're not expecting that. And of course, you can fight back. If you have styles in here, inside the shadow root, then that'll apply to this, and you can override it. And it goes back and forth, and then I made it blue, and this goes on and on. And if you get into a real specificity battle, inside the shadow DOM, the actual best practice is to use important, which is really weird, right? Like we were told for decades not to use important. It's actually a very useful thing in the right cases. So one more cool thing, CSS custom properties actually break through the shadow root barrier. And that's super useful. You can style all sorts of configurable things inside your web component with CSS variables or custom properties. And then you can set those in the parent page, and they'll cascade through. That's what the Apple Pay button does. That's why I showed it here. So you can open up things to be configurable that way. All right, so that's sort of like a API overview, very lightweight. Sorry for all the code at 8 at night. Can they save us? I think that web components are a really good foundation to build on now, because they give us a lot without any dependencies, right? Any libraries that we're adding to the page just to get these features. But they won't make our apps faster on their own, right? It's not like a version we can upgrade to. We can't just automatically transpile our React app to web components. Can we do that, actually? I was hoping. So, you know, the trouble with performance problems is that nowadays they're more social than technical. Like, we have a lot of the tools built into the browser, but there's a lot of momentum behind the patterns that we've been using for the last several years. To a lot of developers today, React kind of feels like a de facto standard, even though it isn't, right? It's where the ecosystem is. There's a component for everything that you can go grab. And it demos really well. And, you know, by comparison, web components kind of don't, right? Like, the community has not come around to building on top of this, even though the tools are really there. It's not a technical problem anymore. We just need more people building on web standards like this. Some good examples are showing up recently. This framework, Web Awesome, just launched. It's built on web components. I think they're a really good example of using them right now. Some of the patterns are very cool. It's worth just browsing through and seeing the code examples and how they compose these things. A lot of them are wrapper components around HTML that already works from the start. You can put two images next to each other and get a compare slider like that. They have a declarative wrapper for intersection observers. So like as something enters the viewport, you can use attributes to declare what it should do. Stuff that usually takes a lot of JavaScript and CSS to do today. It's made pretty easy with this. If you're using web components in that way, wrapping already functional HTML, I think that's the best way to start anyway as a default. My friend Jeremy Keith calls these HTML web components. And basically it's a good way of ensuring that if anything goes wrong, as things do on the web, you still have something useful. This is one that I built pretty recently. It's a QR code generator. It starts by wrapping an ordinary link. So this is like the destination I want for my QR code. It's a functional link, but I put a wrapper around it, a QR element. And this is the entire code of that web component. Now, in fairness, I did import a QR code library, line 1. But that library only generates a QR code from a URL string, right? That doesn't do everything I want my component to do. I want that to happen from a link in the page, right? So the rest of this, finds that link, gets its href, creates a QR code right here, creates a canvas element, sets it as a role of image for accessibility, gives it a ARIA label for accessibility, bubble, and then appends it to the page, and you have a QR code just before the link in the page. So that's like an example of the kind of workflows I like to use web components for. But just like we may not need frameworks for things the browser can do, I think we may not need components for a lot of things anymore either. It's a good thing to keep an eye on. Maybe you remember this site. You might not need jQuery.com. Yeah, when this came out, like people were mad. They're like, we still need jQuery. I was on the jQuery team at the time, and those guys were right. These guys, these people. I think we're in a similar moment now with React, with components, with JavaScript. We may not need them, right? There's a bunch of new stuff landing in HTML and CSS lately that can let us delete a lot of JavaScript. I'll give you some examples. Popover. Anyone use Popover yet? Awesome. Yeah. It's like full interactivity to pop open a little dialogue. You can style it. You could have something come in from off screen for the side navigation. It's very cool. No JavaScript needed for that layer of interactivity. I learned yesterday that you can use details elements now to make an accordion. How's the accessibility on that, by the way? Do you know? Like, no good or don't know? Okay. I'm going to guess, I don't know. But it's interesting. This is like a new feature. If you give each details element a name attribute, the same name attribute, they'll control each other like an accordion. That's like a common thing that you see on UI toolkits that use quite a lot of JavaScript to do that, right? We're getting native stylable select elements soon where you can like put icons in the options. I think a couple browsers already have this. It's very cool. CSS alone. View transitions. Brent here was playing with these last week at Squarespace. It's just like a line of CSS or two, and you get these rich transitions between separate documents, right? Like people use SPA frameworks just for this effect, right? And now it's built into the browser, so worth keeping an eye on. But when you do need components in general, and I think web components are a good option to consider, how do we start making the transition, right? A lot of teams are making what I'd call a transitional approach to them. So let's say you have a big React app. Maybe you can start chipping away at rebuilding some of the smaller sort of little components within your React app as web components that work on their own. Maybe they get passed in some information through attributes, but they handle their own logic, right? And then eventually, or for a little while, the React part can stay as an architecture, but maybe over time, we don't need the wrapper anymore because browsers are getting better. Maybe your components can live in this other app without React because they don't need it anyway. This transitional approach is working really well for a lot of companies because all major frameworks now support custom elements, like 100%. This customelementseverywhere.com, React was the last framework to finally, with version 19, have custom elements support. So yeah, you can just treat them like any HTML you're exporting when you're rendering in React. I think that's a good pattern. It's a good way to start, piece by piece, moving our way away from frameworks. If you're building components that are pretty complex, lots of nesting, I'd say check out Lit. It's not the tool that I would reach for a website, but if I was building Slack or something, it's probably smart. Lots of built-in, handy, sort of React-like patterns, really, but written in web components with very, very low overhead. It's like 2 or 3 kilobytes instead of, I don't know how much React is. So worth checking out. It's very cool. Photoshop runs on Lit under the hood. And a cool thing about web component libraries like Lit is they're literally just web component classes under the hood. And we can make those ourselves too. So we can make our own little class that, extends the HTML element, like this base element does. And then this one can extend base element and inherit whatever we set in this one. So you can start to make composable little base classes like this one where I just rebuilt jQuery, sort of, right? So like here, you can do this dot $, and run query selector and find a paragraph. That example comes from this article by this author, Mayank. And I'm going to leave this with you as like homework. If you haven't read this article, I think it might blow your mind. I just came back to it a couple nights ago, and I was still like, I can't believe how much magic is in this one article. It starts with that jQuery kind of example, but it just goes and goes, and it's really quite cool. So I'll send a PDF around for that, for anyone who'd like it. So to wrap up, web performance. It's at a weird place right now. Standards are changing really rapidly. I think most of our performance problems are cultural rather than technical at this point. We've become really overly reliant on libraries, proprietary libraries, too much JavaScript on the client, too much rendering HTML with JavaScript. Web components, really nice primitives to consider for potentially moving to, but web components alone won't save us. They can't save us, but they can give us new tools for common tasks and an opportunity, I think, to rethink how we deliver our websites. So they can't save us, but you can. Yeah, good luck with that. That's all I have tonight. Thanks. If you're interested, Sergi mentioned I have a course on web components. This was like a small subset of the 8 hours of material. If you want it, it's $25. You just use that code 25. So yeah, thanks so much.
Thank you, Scott.
All right.
Okay, we can now open to questions.
Hi, yeah, for the QR component that you made, you used prepend. Did you need to use a slot at all for that? Like, when do you have to use slots? Like, because do they normally display the inner HTML content or not?
Right. So no, you can just use ordinary DOM methods on the light DOM, so to speak. you don't have to use Shadow DOM ever in a web component. And you might be surprised to hear that if you've seen any web component libraries in the last several years, because most of them go to Shadow DOM immediately, right? But yeah, you can just treat it like any other element. I would say Shadow DOM is a last resort, and it's useful when you want it.
Hey, Scott. Question for things like state management. In React, you have a state manager, and a big problem is you make a change, the whole component could re-render. Is that something you have to worry about with web components? And if it does re-render, is it so fast that you don't care? Just
Yeah. I don't want to overpromise on that answer without knowing having too much familiarity. I will say you're going to benefit performance-wise from using browser-native methods. Attribute change, things like that are just going to be received quicker than whatever layer of simulated events that your library provides. But I don't know. It's probably comparable because the re-render, so to speak, isn't something that web components really give you natively. So there's going to be some library code of your own doing that part, whether it's like lit or something like lit has, for example, an HTML method in it that is for rendering and re-rendering the same template with new information. And it's really optimized in ways that other frameworks are to not re-render if you are changing two attributes really quickly and you don't want two renders in there. But yeah, that's all I can say. It's not at a certain level. It's still user code. So yeah.
Hey,
Hey.
so with the slots, are you able to specify what types of elements go into which slots?
That is a great question. So slots come in a few variations. There's named slots, there's anonymous slots. I showed anonymous ones. They have no attribute on them. That's just sort of like a catch-all for anything that is inside the element. Because by the way, if there's a slot, the light DOM, all of the elements inside the custom element are going into that slot, one or another. You can't have slotted content next to light DOM content, both being rendered. It all gets tossed into the slot. Named slots are pairing certain elements by named attribute to the slot that they're supposed to go to. So it's not like a tag name, but you can assign them in that way. So you could have 3 slots and they each have a different name on them. I think it's name attribute. It's been a minute, but yeah, you can decide which elements go in which. And then there's manual slot assignment in JavaScript, not a declarative thing, but if you're scripting it, where you can specify this element should be appended to this slot, even if they're all unnamed. But yeah, I think you can get there, but it's probably through the naming attributes. Hey, Pavel.
Hey, Scott. Thanks for the talk, and
Yeah.
highly recommend the course.
Oh,
I
thanks.
went through it. It's great. Please sign up. My question to you is, what are some exciting new features on the web related to web components / web performance, unrelated things that either have just become available everywhere or are not available in all browsers? So what's most exciting to you?
Yeah. Well, I guess I can speak to this because it's public. My team was recently working on adding a new feature to HTML. There's a comment thread in the What Working Group HTML spec for the async attribute to be added to the video element. It already works on image, iframe. You can go to that issue in the tracker and read about it. But yeah, I put a comment in there yesterday. We're committing to the spec and browser changes. So that's exciting to me because I'm working on it. But what else? The Web Components community group has a bunch of proposals, and some are ahead of others in likelihood to land. And DOM parts is one that I saw recently that's sort of like a templating approach, like what we want a template to do with like tagged variables inside it. I think it's called DOM parts. There's a lot in that kind of space that I'm into, but I think some of the, like popover and things like that are probably what I'm into that are already working. Yeah. Do you have any favorites recently?
What's it called? Anchor positioning.
Yes. Yeah. Anchor positioning. That's awesome. I haven't used it yet, but just demos. Yeah. Cool.
Scott, hello. Thank you for the talk. I'm also happy to see that you're using Vimeo player for this, because I'm from Vimeo. Does it work?
Oh, you're from Vimeo. Nice.
Yeah. Oh, okay. So I have two questions. One is quick question. When did you start to learn about web components? Because I experienced them in 2015, and it was not a pleasure experience with Polymer
No.
and stuff. Okay. And then second one, if you have any examples of production-ready components you shipped at any company you worked on.
Of any, sorry?
If you shipped it in any company you worked for.
Shipped web components?
Yeah.
Okay. Let's see. I got stuck on thinking about that last question. I've shipped a bunch on my blog. Responsive video is a feature that I worked on, like with the Firefox patch for it and things like that, to make the video element work like responsive images. That's in browsers now, yeah. And each source element can use a media attribute. Unfortunately, it only gets assessed when the page first loads. So you're kind of stuck with whatever it chose at that moment. So I wrote a web component that just wraps the video and makes it reassess sources if you resize it. I like things like that, like little tools for things like that. Yeah, I don't know. There's a GitHub project called Awesome Standalones. Funny name, but yeah, it's just like a README, and it's updated frequently with lots of good examples of web components that, yeah, I'd recommend checking that out. What was the first question again? Sorry.
When did you start to learn about them?
Oh, about them, yeah. So the first question, when I started to learn about web components, was the wrong time. The spec version 0 was not good. And it was kind of like things landed in Chrome that were undone, and the spec got a lot better in version 1. But in those days, a lot of people got turned off by web components. Polymer was sort of known as like the same thing as using web components because they didn't really work cross-browser. So you needed this library that was kind of as heavy as any other framework or heavier just to use them. And it's like, why would I use this? Yeah, so it was a rocky start. I learned about them and forgot about them then. And yeah, I think like, I don't know, maybe like 5 years ago or so, I started learning about them. And I created that course actually to learn about them because there wasn't like some resources like that out there. So yeah.
I have a question. A lot of web performance people, they like to geek out on numbers and measurement, for better or for worse. Are there any challenges or special formulas to measure web components, or how they render, whatever else you can measure around them, you know?
Yeah, interesting. I mean, they're just HTML, you know. So I would lean on saying they're measured alongside the rest of the page. But
you did mention like lifecycle methods, which
Yeah.
fire probably at better moments, which
Yeah.
probably can allow for that.
Right. Yeah, I guess if you were like really going all in on them and made like a single page app or something, then you're going to run into this situation sort of known as a soft navigation now, where the whole screen changes, but you didn't actually refresh the page. And that's like what React is known for, right? Like you're in the same URL for you're stuck. You might change the URL, but you're not refreshing the page. In those situations, there is, it's behind a flag right now, I think, but soft
The
navigation.
soft nav spec?
Yeah, like basically LCP is classically largest contentful paint. It's not a good metric for measuring soft navigations, only real ones or real refreshes, but they're fixing that. And this new soft navigation sort of subset of LCP will give you the speed of those like page refreshes. And I think that's sort of like a re-render that you would get in a web component if you were using
It's
them that
actually
way.
in Origin trial already. So
There you
if your website wants to try them out and participate in the trial, provide feedback, well, in this case to Google's team, or Chrome, no, Google's, I forgot if it's Chromium or Google, I think it's Google. But you can participate. So it's next step after being behind the flag.
Yeah,
So
yeah.
it's pretty useful, especially if you have a very popular website. They can appreciate your feedback, just so you know how technology is done. You use it, give them feedback, they improve it. If you don't then give them feedback, it will be shitty, as version 1.0 spec.
Yeah,
I'm just
right.
saying, like it will not be shitty, but you know what I mean. Participate. We all participants. Sorry for side track.
That's a great point. And I will say that having seen a few teammates get introduced to web standards in the last couple of weeks and like contributing, writing browser patches to like learn how it works, they were all shocked at how accessible the process is to just be involved. Like you can send a pull request to the HTML spec. Just do it, like, well, don't just do it, but like you can, but you can, it's all, that's what it's there for. It's really open. So yeah, I agree.
Standards are made by people like us.
Exactly.
All of
Yeah.
us. I don't mean us. I mean us.
Sure.
Yeah. Do you need the resume after you did standards? I don't know.
Hey.
Hey.
Good talk.
Thanks.
I really enjoyed it. Thank you. A performance adjacent question about web components. How easy it is to work with them on the server? Like if I want to render something in like an aesthetic markup that like the server will send to the client, how easy it is to do with web components? Not easy.
The story is not good there. Yeah. So I will say that there's a company that built a framework called enhance.dev, and it's still available in open source, but it's become a little less actively developed because that team joined another company and they're busy. It's still my favorite way to build with web components. Basically, you define single page components with their markup, their styles, and their scripts in a file, and you can then use that tag to just sort of like compose an app on the server side, and it comes through as static HTML, but it also ships, it's like React or anything like that, like a Next.js sort of, parallel. That one works great, but it's pretty strictly built for like shipping Amazon worker kind of apps, so like Amazon functions. But that is one. I hope someone like extends it. Lit, the framework has a SSR, I don't know, module or whatever that has been in development for years, and it's still called like Lit Labs. I don't know where it's at, but yeah, this is a real problem. Like if you're writing JavaScript to generate the innards of a web components markup, the server doesn't really have anything to do with that. Like web components are a client-side feature. They're a browser side. So there's work to be done there. I mean, it's like, I feel like it's low-hanging fruit. Like someone needs to be building this. But the short-term answer is like, if you're not rendering your content with JavaScript and you're just serving it with some server-side language, then it can be right inside a custom element, and then that markup can be extended further, which is good because it's less scripting for the browser to do later anyway. But if you're building an app, it's a real problem. Like, yeah, something to be aware of. I'm glad you asked that.
Hi, thank you for the talk. Have you found any company that has published stats or information on like their improvements to core web vitals after maybe transitioning to web components?
Yeah. Well, Microsoft wrote about how much faster Edge is now. It used to be built in React, actually, like the Chrome of the browser. And yeah, they had specific numbers. I can't remember what they are, but they were making noise about it. I don't know. Nothing else comes to mind, but there have been, yeah, other case studies. Yeah.
We need webcomponentstats.com.
Yeah, we do. Yeah. Need more people just building on them too. Yeah.
And one from me. If you are, first, thanks for the presentation.
Oh yeah,
Well
thanks
done.
for coming.
If you're to be building your website from scratch, what use cases would you say we can direct developers' attention to use web components versus other technology to render the same thing?
Yeah, so like for learning resources or for reusable like utilities to pull in?
Reusable utilities.
Okay, yeah. I mean, there are some, like WebAwesome is one UI design toolkit that gives you a lot of pre-built components, and they're open source. That's a good one to look at. I also feel like their patterns are pretty nice to be able to just figure out how they work, just like looking at the code. It's pretty readable. And then that other standalones, awesome standalones, I think it's called, has just a really good list of, like, they only make the list if it's a good example and a good pattern. So I'd recommend looking at that. Yeah.
And what are the good use cases to tell developers, no, don't do it this way, but use web components for it?
Yeah, I mean, it depends what you're trying to build. Like if you're building Slack, then you're probably going to reach for something that's a very different style of web component development that's more like using a framework like React. That's what lit is for, right? And I would say, like, if you're setting out to build something that complex, it's good to just start with lit. It's like a really nice boilerplate and it's lightweight. But otherwise, I mean, I personally like to recommend using it for just anytime you would be writing DOM scripting and enhancing something in the page to do something more, you know, a header component that turns into a, well, I don't know, we can do that with popover now. So like more and more, it's like, you know, you have to step back and be like, do I need to write this with JavaScript or a web component in the first place? But yeah, I think lightweight enhancements, if it's a regular website, is kind of where they shine. And embeds, like for other sites, to like the Apple Pay kind of example. Yeah, but
I actually want to piggyback on that question a little bit. So you kind of talked about like building for other websites or for your website, but I think there is something in the middle where there is a platform team usually that needs to increase adoption of some best practice among product teams. At least that's what I heard. Mm-hmm. Is that a good place to use web components?
Yeah, I didn't really talk about it much, but I'm glad you brought that up. The design systems kind of community has really been moving in this direction. Even if they build React apps, the little leaf nodes are more and more web components, right? Because they're portable, and like you can write JavaScript that's not dependent on other, you know, library dependencies, just handles their own business logic, and then put it inside a React component or don't. More and more teams are doing that. So yeah, if you Google that, like design systems with web components, I know like ING is really popular for having I think it's called Lion or something like that, framework that they released open source, I think. Nord is another one. Sorry, like type that into your phone. Yeah, anyway, design systems is a big use case now, because a lot of teams are getting tired of the upgrade, you know, churn, right? New versions come out, it's like everything, it's a headache, right? And the thing about web standards is most of the time, once it's in the browser, it can't change, right? So like the API is set. Some things have changed, but like it's rare. It's not like a React upgrade where a lot of things kind of change and you need to change your own code. So yeah,
Thank you, Scott, for today's
for
lecture. I
coming.
learned something new. Trying to wrap my head around about these web components. So you mentioned we don't use library to install them. So how do we like make these web components? Second question: once we make these components, what kind of advantage they give us? And the third one: can we use it like with like JSX code to kind of mix it up?
Yeah.
Thank you.
Okay. So how do you make them? Well, I think one of the first slides I talked about the life cycle. It's built into the browser. Like if you go in your console and type custom elements with a capital E, it'll autocomplete, and you have the define method, and then you keep going and you give it an element name, and then you pass it the behavior. Like you didn't include any library, so that's like the starting point. But then most teams will put that in a JavaScript module file, right? And that can be imported into your project just like any other JavaScript module, and exported too, right? So a lot of teams will like write a web component class, export that class, another file imports the class, defines an element using it, and that's a common pattern. Or you import a few and extend based on bases, base, and then you get your sort of compiled one. What was your third part? Sorry.
Yeah. Can we combine like with the other like frameworks?
Oh, like JSX was your question. Yeah. So I would say, first of all, look at lit, because by default, it's not JSX. It does support JSX as like an option. But its syntax is template literals in JavaScript, and they're quite nice. But yeah, it's not quite JSX. But yeah, you can get both options through lit. And honestly, if you're doing something that like has a lot of re-rendering on the client, I would look at that. Most teams I've seen are like, we're going to do this with no boilerplate, and then a month later they're like, we're going to lit. You know? So yeah, keeps happening. Yeah.
Okay. Thank you, Scott.
Yeah. Thanks, everyone.